Howdy, AP PreCal. It is Ms. Kosh, and actually this is good for my IB classes too. So anyone who wants to study trig, I am updating the way I teach double angle identities. And at the beginning, here's a shout out to my nephew. He wanted me to advertise our concert. My sister, and me, the three of us all play in an orchestra, and we have a concert coming up. Okay, you're welcome, Michael. Okay, so on this one, we're gonna use the sum and difference identities, which you may or may not be able to read right here, to help us prove the to generate, to develop, to prove whatever the double angle identities. And once again, AP PreCal doesn't require us to know the tangent identity. But here it is in case you're curious. Okay, so with sine, we know that 2 theta would be equal to theta plus theta. And so I can do the sine sum identity, which is sine, cosine, cosine, sine with the same SIG in. So I write sine, cosine, cosine, sine with the same SIG in. And so here's the first angle, here's the second angle, here's the first angle, here's the second angle. You may notice they were all the same angle. And so I have one term here that's sine, cosine, and I have another term that's sine, cosine. And so this would be equal to 2 sine theta cosine theta, which is the identity right here. Will they give this to you on the AP exam? No, they will not. You need to know it. Practice, write it down every time, and then you won't have to worry about memorizing it. Okay, so now we're going to do the similar thing with cosine. And the cosine identity is cosine, cosine, sine, sine with the opposite SIG in. Cosine, cosine, sine, and I'm not going to do tangent, so I'm invading that space, with the opposite SIG in, and so it was the first angle, the second angle, the first angle, the second angle. But they're all the same. So cosine times cosine, you may know to be cosine squared theta minus sine squared theta. And now this is how we begin with that, but keep in mind we can use the Big Daddy and say this is 1 minus sine squared theta minus another sine squared theta, which gives me 2, well, a negative 2 sine squared theta. Can you read that there? Here's this one. And then I also could come back to the previous statement here, and I know that this would be cosine squared minus, well, sine squared can be written as 1 minus, oh, that's not what I wanted to write, cosine squared theta. And now I have a negative 1 and a positive cosine squared. So there's one positive cosine squared and a second positive cosine squared, which gives me this identity right here. So the good news, bad news with cosine of 2 theta is that there are 3 versions, and sometimes it's hard for us to know which to use. Sometimes it doesn't matter, and other times it makes a big difference. But because they're kind of manipulated from one another from the Big Daddy, you'll start to see when to use what, and then if you use the wrong one, you can get to the right one without too much effort. Okay, so now let's do some proofs or some examples. So this first one here, am I in focus? On this first one, they're telling us prove that sine of 2 theta over 2 cosine theta is equal to sine of theta. Well, sine of 2 theta, we just said, was 2 sine theta cosine theta, and it's currently being divided by 2 cosine theta. If I put this on the test or quiz, you should say thank you, Ms. Kosh, because they really don't come much easier than that. And this is sine theta equals sine theta, and we're done. Okay, the next one, find sine of theta and find sine of 2 theta and cosine of 2 theta when cosine equals negative 3/5, and theta is between 3 pi over 2 and 2 pi. So 3 pi over 2 and 2 pi puts us down in quadrant 4, and the cosine value, oh, I made a mistake. 3 pi over 2, the cosine in that quadrant is positive. Okay, maybe I'll fix it on the other version, but I'll definitely fix it in class. That's my bad. I must have made this mistake years ago and corrected it in class every time and never bothered to type it up because I didn't write this problem this year. Okay, so that's 3 and 5, and this would have to be a negative 4. So the sine value is negative, but the cosine's not. And so this is sine of theta would be equal to, sometimes it's helpful to write it down for us, negative 4/5 in that quadrant. Okay, so let's zoom out a little bit so you can see everything that I'm looking at. I want to do sine of 2 theta. This would be equal to 2 sine theta cosine theta. And that is 2 times, well, we know a value for cosine theta. And it is, I lied, that didn't say cosine, it said sine. And that is negative 4/5. And we know a value for sine of theta, which they wrote down, and I corrected it, my apologies, it's a positive 3/5. And so I see 4 4 times 2 is 8, times 3 is 24, but it was negative. And that is the sine value of that ratio. Okay, cosine of 2 theta. What I would suggest we do is use the value that they gave us just in case we messed up over here. And so let's use the formula that has cosine and only cosine. Now, does that mean it's the only way to do this problem? Nope, but it's how I'm going to show you. Okay, so it's 2 cosine squared theta minus 1, which means 2 times that cosine theta value squared minus 1. What was that cosine? Well, it should have been a positive 3/5. Squaring it, it's still positive anyway, but there we go. Okay, so I see 9 over 25, and 9 times 2 is 18 over 25, minus this would be 25 over 25, and I get a negative 7/25 for that one. Cool. Okay, the next one, example 3, if theta is acute and cosine of 2 theta equals 3/4, find cosine of theta. Now, why did they tell us that theta is acute? Well, they told us that because technically we might have, our cosine ratio could be positive or negative when we do the work, but because it's acute, that means it's in quadrant 1. Are they acute angles? That means cosine has to be positive. Okay, so I have 2 theta is equal to something, cosine of 2 theta is equal to something, and I want cosine. So let's write down that formula, 2 cosine squared theta minus 1, that just has cosine of regular theta and cosine of 2 theta, okay? And now I can plug in what I know. This becomes 3/4 is equal to 2 times cosine squared of theta minus 1. What do I do first? I add 1, that gives me 7/4, and then I'm going to divide by 2. That gives me 7/8, and I didn't have enough space to show you all my work, and I apologize, but there you go. Okay, and now technically when we take the square root, we would say square root plus minus, but they told us it's acute. And so we only want the positive. So cosine of theta will be equal to plus or minus just the plus root 7 over, well, this is 2 root 2, but let's rationalize our denominator because that's what AP PreCal wants us to do. And so I get the cosine of theta is equal to root 14 over 2 times 2 is 4. Cool. And we want the positive. It was plus or minus. The minus means that we have an obtuse angle, but they told us it was acute. Okay, solve for all values of x when sine of 2x minus. Okay, the worst thing you could do would be to try and factor out an x right now, because this is, anyway, you're like, oh, look, the only thing that's different is, no, that's totally bad math. What we have to do is come along and rewrite this using our identity. And so this is 2 sine x cosine x minus sine of x equals 0. I can factor out a sine of x. When I do, I'm left with 2 cosine x minus 1. And now I have the scenario where sine of x equals 0, or cosine of x add 1 divided by 2 is equal to a positive 1/2. They said solve for all, so that's going to be plus 2 pi k, where k is an element of the integers. Okay, so so just a reminder, hopefully you don't have to write this. Sine is 0 here and here, and there's a pi k apart. We can just say pi k. And then cosine equals 1/2, that's here and here. So it's pi over 3 plus 2 pi k. I did not save myself enough space. And it is also 5 pi over 3 plus 2 pi k. All right, like, subscribe, comment, and let me know how I can help you. And of course, you can't learn math if you don't practice, so go practice.